Welcome back to Crash Course Trigonometry, where I go over the basics of trigonometry and try to give you a better understanding of the topics. Today we are going to be learning about circular functions, arc lengths, and sectors. So we're going to start off with the third definition of trigonometry, which is if xy is any point on the unit circle, which is a circle that has a radius of 1 and center at the origin, then and t is the arc length created by the central angle theta that runs from 1, 0 to xy. So there's a lot of words there. Arc length is the length of an arc of a circle. So if you have, an angle in standard position, x-axis, and any point on the circle, xy, then the arc length is the length of the arc cut off by both lines of the angle, the initial side and the terminal side. So the arc length is the length of that section of the circle, the circumference of it. And then the central angle would be theta in this case. It's the angle that makes that cut. So theta, right there. And then if it runs from 1, 0, which would be right here, making sure it's a unit circle, to xy, which would be the point on the end of the terminal side of the angle, then we can use these trigonometric functions and, find more variables of what we need. So if we know that t is the arc length over here, it's that green section, then sine of t would equal y, cosine of t would equal x, and tangent of t would equal y over x. And now if you remember in the last section, we talked about how cosine is usually x and sine is usually y. Sine is how high is the y, and cosine is just x, So using these trigonometric functions, they're pretty basic. There's only 3, and it also works with their reciprocals. We can see that sine of t is y, cosine of t is x, and tangent of t is y over x. Next, we're going to move into calculating arc length, and there's only one equation for doing this. The equation is s equals r theta, where s is the arc length, r is the radius, and theta is the central angle, which is right in the middle. So if we use s equals r theta, and we have 2 parts of that equation, we can find the third part, just like any other equation. S is the arc length, which is right here. Radius is r, which is the radius of the circle. It could be there, it could be anywhere, it's a circle. And theta would be the central angle, which cuts the arc length off. But here's the kicker. Theta for this equation has to be in radians. It must be in radians or it does not work. This equation will not work with theta in degrees. So theta must be in radians. So if you're in degrees, you have to change it to radians using pi over 180. Next, we're going to move on to sectors. So what is a sector? A sector is any section of a circle from the arc to the center. So like this would be a sector over here. If I just take this whole quarter, that would be a sector. A sector is just an area of a chunk of a circle. And you can find the area of a sector using a equals 1/2 r squared theta. And again, theta must be in radians, so make sure to double check that before you try to use this equation. Here I have 2 examples of the equation s equals r theta. One of them involves arc length, and one of them involves finding the area of a sector. So let's start with finding the arc length. So we have to find the arc length of the arc cut off by a central angle of 2 radians in a circle of radius 4.3. So we already have theta, and it's already in radians, and we already have the radius, which is r. So using s, so we know that theta equals 2, and r equals 4.3, right? So using s equals r theta, we find that s equals 4.3 times 2. And our final answer comes out to s, which is the arc length, equals 8.6. And that is our simple answer. You just take the variables that you have and use them to find the variable that you don't. Next, we're going to move on to the area of a sector. So we have to find the area of a sector formed by central angle theta, which equals 1.4 radians, in a circle of radius 2.1 meters. So we could draw the circle, this is 2.1 and here's theta and all that fun stuff. But if we just use the area of a sector formula, which is A equals 1/2 r squared theta. Then we can find the area of the sector really easily. So we have A equals 1/2. We know that r is 2.1 squared times theta, which is 1.4. And then if we use our calculator, we find that A is equal to 6.3. 6.3 meters, because the radius of the circle is in meters. And what that basically means is if we use this circle as an example, and this is our sector right here, the area of this section of the circle is 6.3 meters squared, because it's area, so it always ends in squared. So that's the basics of finding the area of a sector and the length of an arc of a circle. That's the end of this chapter, and I hope it helped you at least a little bit to figure out how to use circular functions and all that. I hope you have a wonderful day. Bye!